Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I'm going to walk you guys through how to solve each of the problems on our Unit 3, our test number 3 review on basic proofs and triangles. My disclaimer as always is I need you guys to work every problem, each problem on the review, and then and only then come to the video and see where you might have some misunderstandings or to check your work to fill in any gaps. So let's go ahead without further ado and jump on in here. So here's a list of the things that you guys need to study and be ready for on the test. So these first 5 problems, we're going to go back and look at our laws of detachment and our laws of syllogism. So in problems 1 through 5, they're saying if possible, use the law of detachment to make a conclusion. If it's not possible to make a conclusion, tell why. Okay, so in this first one here, now remember with the law of detachment, you only have one conditional statement. Okay, with the law of detachment, you have if A, then B, and then the next statement, you have A. And so I can conclude B. Okay, so if a doctor suspects her patient has a broken bone, that's my A. If that, then B, she should take an x-ray. Okay, and then it says Dr. whoever that is suspects Lily has a broken arm. Okay, so if they suspect a broken bone, we should take an x-ray. We got a broken bone, A. Conclusion, then she should take an x-ray. Okay, so in all these laws of detachment, I'm just looking for A, then B, and then the next statement is just repeating the A again. If a rectangle has side lengths of 3 and 4, that's my A. Then it has a square area of 12 square centimeters. But then it says rectangle ABCD has an area of 12 square centimeters. That's a B. Okay, if A, then B, and I have B. Okay, I can't do anything there. I can't make a conclusion. For law of detachment, that second statement has to be some kind of repeat in basically the same amount of words, a repeat of A. Number 3, if 3 points are on the same line, they're collinear. Okay, if they're on the same line, they are linear. Points X, Y, and Z are on the same line. So if A, then B, I have A, so my conclusion is B. Then they are collinear. All right. Number 4 is a little tricky. Number 4 says if an angle is obtuse, A, then B, it is not acute. But then the next statement says angle XYZ is not obtuse. We have this word not in here. So that is not a repeat of A. That's basically the opposite of A. And it's not B either. It's not obtuse, but it's not saying it's acute either. So this is like a C. Okay, if A, then B, and I have a C. There's nothing I can do there. I can't make a conclusion. If it's not obtuse, I can't make a conclusion of whether or not it's acute. You might say, oh, well, if it's not obtuse, then it has to be acute. Not necessarily. Okay, what about a straight angle? What's the measure of a straight angle? That's 180 degrees. That's not obtuse or acute. Okay, that's a straight angle. Okay, so I can't make a conclusion there. Number 5, if a student wants to go to college, A, then the student must study hard, B. Rashid wants to go to college. Okay, I have A. If I go to college, got to study hard. Wants to go to college, conclusion, then Rashid must study hard. Okay, that's the law of detachment. When I only have one conditional statement. All right, the next few we're going to look at law of syllogism. Okay, syllogism, I have 2 different conditional statements. If A, then B, and then if B, then C, then I can make the conclusion if A, then C. I can go straight from A to C. So number 6, ecology, says if an animal is a Florida panther, A, should be Carolina Panther. The Carolina Panthers NFL. But anyway, we're talking about Florida. If an animal is a Florida Panther A, then its scientific name is Puma concolor corii. I don't know how to pronounce that. I'm a math teacher. Then its scientific name is something. Okay. If an animal has that same name, there's my B again. Okay. So if A, then B, and then if B, okay, if an animal has that name, then C, it's endangered. Okay, if A, then B, if B, then C, then I can jump straight from A to C. So my conclusion is if an animal Animal is a Florida panther. I'm going to abbreviate here just for sake of this video. Then what? It's endangered. Okay, if it's a Florida panther, then its name is that, and if its name is that, it's endangered. Well, this animal is a Florida panther, so it's endangered. Sorry, y'all can't see that. It's endangered. All right, number 7. If a whole number ends in 6, okay, A. If it ends in 6, then it's divisible by 2, B. If A, then B. If a whole number ends in 4, that's something different. We haven't seen that yet, so that's a C. Okay, then it's divisible by 2. I have B again. I can't go from A to B and then C to B. And that doesn't work, okay? So there's no conclusion I can make there. Okay. Number 8, if a line intersects a segment at its midpoint, if A, then the line bisects the segment, then B. If a line bisects a segment, B, then it divides the segment into 2 congruent segments, C. If a line intersects at the midpoint, if A, then B, it bisects it. If it bisects it, B, then it divides it into 2 congruent segments, C. So I can jump straight from A to C. Now, for sake of this video, this is a long one. I'm not going to write out this whole thing. My conclusion is this first part, that's my hypothesis. And then my conclusion is this. Okay, so if a line intersects a segment at the midpoint, then it divides the segment into 2 congruent segments. All right, number 9, if you improve your vocabulary, A, then you will improve your score on a standardized test, B. If you read often, okay, we haven't seen that yet. You might say, oh, well, if you read often, you improve your vocabulary. I don't know, maybe not necessarily true. Depends on what you're reading. Okay, if you're reading computer programming, then and just look at reading numbers, and that's not going to help your vocabulary. So if you read often, that's like a C. Then you will improve your vocabulary. That's A again. I've got A and B and C and A, and that doesn't work. Okay, no conclusion I can make there. So just to recap, for law of detachment, you have to have A and B and then another A. That's detachment. Okay, for syllogism, you have to have an A and a B and then a B and a C. Okay, and those are the only ways you can set that up so that you can make your conclusion. All right, so let's move on here, on to the proofs. Number 10, angle CDE and angle EDF are supplementary. That means they add up to 180 degrees. Angles that form a linear pair are supplementary. Okay, so these two angles, they form a linear pair. They're supplementary. So it says the measure, now the little m right here means the numerical value. Okay, students seem to get this confused. The measure of angle ABC and then angle ABC. Those are two different things. Okay, angle ABC might be its color, its location, its position. The measure of angle ABC is the actual numerical value, 80 degrees, etc. Okay, so make sure you don't get those confused. Okay, so they're saying the numerical value of angle CDE plus the numerical value of angle EDF is 180 degrees. Why is that? Okay, angles that form a linear pair are supplementary. Okay, that's just the definition of supplementary. They add up to 180 degrees. So in this first one, I would put definition of supplementary. Okay. All right, the second one, they put X. Angle CDE is X, so they stuck that there. Angle EDF is 3X plus 20. They stuck that right there. So they said that guy is an X and that guy is a 3X plus 20. So all they did is they substituted in the expression for each of these angle measurements. So this is substitution. Okay, but I can't just say substitution. It's substitution property of equality. Now, again, like we said in class, POE just means property of equality. So I'm just going to abbreviate that. Okay, what did they do here? X plus 3X is 4X. So they combined like terms, CLT. You could also put simplify. Okay, but we combined our like terms, CLT. All right, then we subtracted 20 from both sides and got 160. So that's subtraction, property of equality, subtraction, PO. And then we divided both sides by 4. So that's division, PO. Division property of equality. Notice we have equal signs everywhere. So all of our properties are going to be property of equality, property of equality. If we had congruent symbols, it would be property of congruence. Okay, the next one, xy is 42, xz plus zy equals xy. Okay, so that's given. Okay, so they tell us that xy, the whole length is 42. Okay, that's given. Why can I say that this piece plus this piece, that piece plus that piece equals the whole piece? That's our segment addition postulate. Segment addition postulate just says if I add two pieces together, I will get one long piece. I can't spell. I'm a math teacher. Postulate. Okay, number two. Again, all they did was they substituted in these expressions. They substituted in what we know. So that's substitution. I'm going to abbreviate substitution property of equality. And then right here they distributed. 3 times n is 3n, 3 times 4 is 12. So that's the distributive property. Distributive property. There is no distributive property of congruence or equality. So you don't need to write that. There's no PO or POC there. It's just the distributive property. All right, and then they subtracted 12 from, no, they combined their like terms. 3n and 3n is 6n. So again, they're combining like terms or simplify. Then they subtracted 12 from both sides, subtraction, property of equality, and then we divided by 6, division, property of equality. Okay, so those proofs not too bad when you have to fill in the blanks. Okay, number 12, we got another fill in the blank proof. Okay, given that C is the midpoint, so C is the midpoint, those two lengths are going to be the same. Prove that X is 6. Okay, so C is the midpoint of AD. So what's the first thing we always write down in our proofs? We always write down the given. Okay, they told us that. They literally told us that. Okay, that's the given. All right, AC, this piece is congruent to this piece. What allowed me to put the tick marks right there? Okay, that's the definition of a midpoint. By definition, we're cutting this whole piece in half when we find the middle of it. Okay. All right, AC is congruent to CD, definition of congruency, or they're saying congruent segments have equal length. All right, and then they substituted. Okay, so AC is 4x equals CD, which is 2x plus 12. Okay, so that's substitution, property of equality. All right, and then subtraction property of equality. If I subtract 2x from both sides, I'm going to get 2x is equal to 12. Okay, over here on the left, subtract 2x from both sides. Subtraction property of equality, or subtraction PO. And then we divide both sides by 2 and we get x is 6. That's another division property of equality. Okay, so those are our proofs. 13 through 18 is just testing whether or not you understand your vocabulary. So you got to look back in your notes. Symmetric, what was the word for symmetric? Is kind of switch, right? So when you see the word symmetric property, you need to think switch or backwards. So if AB equals YU, then if I switch that, I'm going to have YU equals AB. Okay, just the reverse, or I'm just writing the same thing backwards. Number 14, symmetric property, again, is switch. So angle H is congruent to angle K. If I switch that, I've got angle K is congruent to angle H. All right, reflexive. Reflexive is something equals itself, mirror image, right? It's the same exact thing. So I have angle POR is congruent to angle POR, reflexive property of congruence. And why do we have this reflexive property of congruence? We'll see this. Continue to see this when we get to triangle congruence, when we need to show that one line is being shared between several different angles. We need to say that POR is congruent to itself, that we can say, if I've got, two triangles or something like this, and I'm putting a tick right here in the middle, I need to say that this line is congruent to itself so that I can say it's being shared with triangle number 1 and triangle number 2. Okay, but anyway, reflexive means it's congruent or it's equal to itself. All right, distributive property, obviously I'm just distributing 3 times x is 3x. 3 times -1 is -3. That's super easy. Substitution property, if LM equals 7, EF plus LM equals NP. So wherever I see an LM, I'm going to replace that with a 7. So I have EF plus 7 equals NP, and that's the only substitution I can do. Okay, transitive. Okay, transitive is like if A, then B, and then if B, then C, and so A to C. It's kind of like our law of syllogism, right? If A to B and B to C, I can jump straight from A to C. So if the angle XYZ is congruent to angle AOB, and angle AOB is congruent to angle WYT, then these two guys have to be congruent to each other, okay? If A, then B, and then if B, then C, A to C. So angle XYZ is congruent to angle WYT. Put some numbers in there. If angle XYZ is congruent to AOB, if angle XYZ is 30 degrees, and it's congruent to AOB, what does AOB have to be? It has to be 30 degrees. And then here's another AOB. If that's congruent to WYT, then WYT has to be 30 degrees. So guess what? XYZ and WYT, they both have to be equal to 30 degrees. Now, again, I'm just making up a number off the top of my head, but just so you guys can see logically how we arrive at those conclusions. Okay, number 19, we got another fill-in-the-blank proof. Given the angle 1 is congruent to angle 3. So this guy is congruent to that guy. Okay, prove, oh, I guess it would help if y'all could see it. Angle 1 is congruent to angle 3. So prove that angle 6 is congruent to angle 4. Why are those two angles have to be the same? All right, so the step 1, the first thing they have in their proof is angle 1 is congruent to 3. Okay, that's given. Angle 3 is congruent to 6. What would you call angles 3 and 6? Okay, they form an X, right? Here's 3 and there's 6. Okay, if they're across from each other in the X, then they're vertical angles. So I could say those are congruent because of the vertical angles theorem, which we abbreviate as VAT, V-A-T, vertical angles theorem. Okay, because of the transitive property of congruence, what is true? Okay, now remember, if A equals B and B equals C, then A and C have to equal each other. Okay, so we say 1 is congruent to 3, and 3 is congruent to 6. So that's like my A and my B and my B and my C. It's like the law, it's kind of like the law of syllogism. If 1 and 3 are the same, and 3 and 6 are the same, then A and C have to be the same. 1 and 6 have to be the same. So angle 1 is congruent to angle 6. Again, put some numbers in. If angle 1 is 40 degrees and angle 3 is 40 degrees, angle 3 is 40 degrees, angle 6 is 40 degrees, 1 and 6 both have to be 40 degrees because of the transitive property of congruence, because we have the congruent symbol here. Okay, so everything in this proof is property of congruence. Okay, so if 1 and 6 are the same, why are 1 and 4 the same? 1 and 4. Okay, 1 and 4, they're across from each other again, right? So that's my VAT, my vertical angles theorem. Okay, all right, so we got 1 and 6 are the same. 1 and 4 are the same. So don't 4 and 6 have to be the same? It's like a triangle, right? 1 and 6 are the same. And then 1 and 4, these two guys are the same. These two guys are the same. So these two guys have to be the same. Okay, I'm trying to give you several different visuals of what transitive property of congruence means. Okay, so 1 and 6 are the same, 1 and 4 are the same, 6 and 4 have to be the same because of, once again, the transitive property of congruence. I'm going to abbreviate. Same thing, we just did it twice. 1 and 3 are the same, 3 and 6 are the same, 1 and 6 are the same. 1 and 6 are the same, 1 and 4 are the same, so 6 and 4 have to be the same. Transitive property of congruence. Okay, let's move along here. On to number 20. Okay, this is the last proof on this review. So we got another fill-in-the-blank proof. I guess you guys probably love those, instead of having to create your whole proof from scratch. Okay, fill in the blank here. So it says all right angles are congruent. Okay, That's given. Okay, all right angles are congruent. So this is kind of different from a two-column proof. This is our paragraph proof, but it's the same concept. Angle X and angle X is congruent to angle Y. Okay, that's what we're trying to prove. And it's telling me that X and Y are right angles. Well, angle X and angle Y are right angles because it's given. Okay, they tell us that right here. By the definition of blank, the numerical value of X is 90 and the numerical value of Y equals 90. Okay, why is that? If this is a right angle, if you tell me that's a right angle, then that means it's 90 degrees. That's just definition. Okay, that's just by definition of right angles. By default, by definition, each of these angles has a numerical measurement of 90 degrees. Okay, by the transitive property of equality, the measure of angle X is equal to what? Okay, so again, when I think of transitive, I think of the triangle. Okay, the measure of angle X is equal to 90. Okay, so I got the measure of angle X, that's equal to 90. The measure of angle Y is equal to 90. The measure of angle Y is equal to 90. So if both of these guys equal the same thing, then don't they have to be equal to each other? They have to be equal to each other. That's the transitive property, the whole triangle thing. If two things are congruent to the same thing, if they're congruent to the same thing, they've got to be congruent to each other. So the measure of angle X is equal to the measure of angle Y. Because angles of equal measurement are congruent, then I can finally prove that angle X is congruent to angle Y. And we usually just write definition of congruence. Okay, they're just writing it out a little bit different way. Because angles of equal measure are congruent, then those two angles have to be congruent. Okay, moving on. Number 21, midsegment. Midsegment is half of the base. How do I know I have a midsegment? I got a tick and a tick, double tick and double tick. So that means this guy right here is a midsegment. So number one, it's parallel to the base. Those sides are parallel, and it's half of the base. So if the base is 30, then X is 1/2 of that, which is 15. Okay. Don't get those confused. Some students will end up multiplying by 2, and they'll say that X is equal to 60, and they're like, oh yeah, 30 is half of 60. Use common sense, guys. This line is shorter than this line, right? This is my base. That's the long one. This is the shorter one. So which number has to be bigger? 30 has to be bigger than 15. Okay, so take just a second and make sure you don't make a quick, careless mistake on something that's as simple as this. Okay, number 2. Wow. Maybe we should pronounce it like that. Number 2. Number 2. I don't know, that'd be interesting. Maybe they actually said it like that, and they just changed it to 2. Number 2, 22. I sound like Elmer Fudd. 22. Okay, this is a mid-segment, all right? So I got a tick and a tick, double tick and a double tick, all right? Now here we can't just say this is half of that because we don't have any numbers. So the way I taught you guys in class is you double the mid-segment. This guy is half of this, so it's going to take 2 of these, 2 x's plus 5s, to equal the whole 3x minus 1. So I'm going to double this guy. When I double it, I say I just multiply by 2, but you got to use parentheses here because you're doubling the whole thing. Double the midsegment, set it equal to the base. Okay, I got to use the distributive property. That's going to give me 2x plus 10 is equal to 3x minus 1. Okay, let's subtract 2x from both sides. 10 is equal to x minus 1. Let's add 1 to both sides. 10 plus 1, and we get 11. Let's check it, okay? Don't just circle it and move on. Let's check it. If I stick an 11 here, 11 plus 5 is 16. So this base better be twice that. It better be 32. 3 times 11 is 33 minus 1. That does give me 32. Okay, take just a second to check your work, guys. Make sure you didn't make a mistake. Okay, number 23 is a very cool problem. I like this problem a lot. Very interesting problem. So, back this up just a little bit. Sorry, I'm trying to back up my laptop so I have room to push this piece of paper back. Okay, that's more better. All right, so in this problem, it says triangle ABC has the following vertices, 0, 0, 2, 2, and 5, negative 1, okay? And it says find the coordinates of L, the midpoint of AC, and M, the midpoint of BC. So let me try to fix this lighting problem here. Did I have a light go out in my classroom? There's a shadow here all of a sudden. Okay, anyway, so we've got these 3 points, so let's go ahead and plot them. 0, 0, that's A, 2, 2 here, that's B, and then 5, right 5, down 1 is C. So I have my triangle here that I can draw. Okay, my triangle. It says find the coordinates of L, which is the midpoint of AC. So I got to find the middle of AC. And then M, which is the midpoint of BC. And then verify that LM is parallel to AB and that LM is 1/2 of AB. Okay. All right. So the first thing I need to do is to find the midpoint of both of these lines. Okay. So to find the midpoint, you guys have to go back, dig deep. Okay. Midpoint is equal to, it's just the average of your x's and the average of your y's. Okay, so your midpoint is x1 plus x2. You're going to add your x's together and divide by 2. And then you're going to add your y's together. y1 plus y2 divided by 2. Okay. All right, so that's my midpoint. All right, so I'm going to find the midpoint of both of these guys. All right, the midpoint of AC. Okay, the midpoint for AC. I'm going to add my 2 x's. Okay, I'm going to add 0 plus 5. And I'm going to divide by 2. And then I'm going to add my y's together. 0 plus a negative 1, which is 0 minus 1. I'm going to divide that by 2. Okay. All right, 0 plus 5 is 5 over 2. And I'm going to change these to decimals because that's easier to plot. So that's going to be equal to 5 halves, comma, negative 1/2, which is equal to 2.5, comma, negative 0.5. Okay, so that is the midpoint of AC. So I'm going to go right 2.5, and then I'm going to go down 1/2. So right there, that's point L. Okay, the midpoint of AC. Check it visually. Does that look like it's the middle? Yeah, it looks like it. Okay, now again, we have to throw our eyeballs in the trash can, but just for visual purposes, yes, it appears that I have done the math correctly. Okay, now I'm going to have to go find the midpoint of BC. Okay, midpoint of BC. All right, so now I'm going to add my 2 x's together. I'm going to add that 2 and that 5. So 2 plus 5 over 2, and then I'm going to add my y's. 2 plus a negative 1, which is 2 minus 1. Divide that by 2. That's going to be 7 halves, comma, 1/2, which is going to be equal to 3.5, comma, 0.5. Okay, so I'm going to go right 3.5, about right there, and then I'm going to go up 1/2, about right there, and we're going to call that point M, which is the midpoint of BC. Okay, all right, so that guy is 3.5, comma, 0.5. This guy is 2.5, comma, negative 0.5. Okay, so now let's draw our midsegment. Let's connect these 2 points. Okay, now 2 things we know about the midsegment. One is we know that it is parallel to the base. Okay, we also know that it's 1/2 of the base. Okay, now so to verify, it's asking us to verify that LM is parallel to AB, that LM is 1/2 of AB. Okay, so again, we know that's true about the midsegment. How do we verify this? So let's go ahead and verify that the midsegment is 1/2 of the base. To do that, I'm going to have to find the distance. I got to find the distance of both of these guys. Okay, so our distance formula, if you guys will recall, it is the differences of your x's squared plus the differences of your y's squared. Because remember, this is basically Pythagorean theorem. This is like a squared. This is like a squared plus b squared equals c squared. Okay. All right. So now I'm going to find the distance. I need the distance of LM. in the distance of AB. I'll do LM first. The distance of LM is going to be equal to the square root of x2 minus x1. Okay, it's going to be the difference of these two x values. Okay, so I'll do this one minus this one because I want to deal with a positive number. 3.5 minus 2.5. So I'll do 3.5 minus 2.5, and then we're going to square that, plus the differences of my y's. Okay, again, this could be like my this could be like my x2, y2, and this could be my x1, y1. So x2 minus x1 plus y2 minus y1. This is 0.5 minus a negative 0.5. So you got that double negative there. Again, it's tricky. Okay, so if I work this out, that comes out to be, that's the square root of 1, 3.5 minus 2.5 is 1. So the square root of 1 squared. 0.5 minus a negative 0.5 is 0.5 plus 0.5, which is 1 squared. So I have plus another 1 squared. That's 1 plus 1, which is 2. So that gives me the square root of 2, which is approximately 1.41. Okay, that's approximately 1.41. All right, so that's the distance of LM. Now let's go find the distance of AB, and it better be twice that. It better be 2.82. Okay, so let's check it. The distance of AB is the square root of, okay, the differences, I'm looking at these 2 points now. Again, this could be like my x1, y1, x2, y2. Okay, so it's going to be x2 minus x1, so 2 minus 0 squared, plus y2 minus y1. That's also another 2 minus 0 squared. 2 minus 0 is 2, 2 squared is 4, so that's the square root of 4, plus 2 minus 0 is 2, 2 squared is 4. So I have the square root of 4 plus 4, which is the square root of 8, and if you type that in your calculator, guess what we get? We get 2.82. Okay, so yes, we have verified that LM is equal to 1/2 of AB. Okay, now it also says we need to verify that the lines are parallel. Now we know with our mid-segment theorem, we know this is a mid-segment. We know that these lines have to be parallel. How do we actually prove that or show that? We could look at the slopes of both lines and show that they're the same. Okay, so if you guys remember, what is the formula for slope? If I have a line, okay, if I have a line, I'm trying to find the slope. Most of you guys remember it's rise over run. Okay, another way to think about it is your delta y over your delta x. Is the change in your y, is your vertical change over your horizontal change. Okay, so I'm going to go back here and draw this here again just so you guys can visually see this one more time. If I want to find the slope between these 2 points, I'll want that vertical rise over that horizontal run. So for my change in y's, this is going to be like y2 and y1. So I'm going to subtract y2 minus y1. And then I want my horizontal distance. This would be like my x2 and this would be like my x1. So then I'm going to do x2 minus x1. The change in y's over the change in x's. So my slope formula is y2 minus y1 over x2 minus x1, which is the same as delta y over delta x. You'll see this kind of stuff. You'll see that kind of stuff in college. The vertical change over the horizontal change. Okay, so if we wanted to verify our lines are parallel with slope, then I can find the slope of AB, which is change in y over change in x. That's 2 minus 0. Okay, y2 minus y1 over x2 minus x1 over 2 minus 0. That's 2 over 2, which gives me a slope of 1. Sorry if y'all couldn't see that. 2 minus 2 over 2 minus 2 is 2 over 2, which is 1. All right, now let's find the slope of LM. Okay, the slope of LM, that's going to be y2 minus y1, 0.5 minus a negative 0.5 over x2 minus x1, 3.5 minus 2.5. 0.5 minus a negative 0.5 is 0.5 plus 0.5, which is 1. 3.5 minus 2.5, which is 1. 1 over 1 equals 1. Okay, the slopes are equal. Okay, so we verified that LM is half of AB using the distance formulas, and we verified that the lines are parallel because their slopes are the same. Good problem. A lot of stuff in that one. A lot of standards wrapped up in that problem. Okay, 24. This is our side splitter theorem. Side splitter theorem. And that says that if I have a line that's parallel, now again, this doesn't have to be mid-segment. Obviously, it's not the mid-segment because 3 is not congruent to 4. Okay, so this is just any line that's parallel to the base divides the triangle such that the ratio of these two sides are proportional. Okay, so we can set up a proportion literally several different ways. Okay, you just got to be consistent. If I go left over right, I have to go left over right. If I go top over bottom, I have to go top over bottom. If I go bottom over top, I have to go bottom over top. The only thing you can't do, you can't go diagonally. You can't do 6 over 4.5, and you can't go left to right equals right to left. I can't do 6 over 3 equals 4.5 over x. You just got to be consistent. I'll choose to go left to right. So I'm going to say that 6 divided by 3. Okay, if I'm going left to right, I have to go left to right. That's going to be equal to x over 4.5. Now, how do I solve this? I'm going to cross multiply, do the butterfly thing. X times 3 is 3x. 6 times 4.5 comes out to be 27. And then I'll divide by 3, and I'll get x is equal to 9. Okay, I'm going to show you a couple different options here. Let's say we went bottom to top. X over 6 is equal to 4.5 over 3. Okay, when I cross multiply, I still get 3x. When I cross multiply, I still get 27. I still get x is 9. I could have gone right to left. I could have gone bottom over top. 3 over 4.5 equals bottom, sorry, I said that backwards. I could go top over bottom equals top over bottom. 3 over 4.5 equals 6 over x. Okay, when I cross multiply, guess what? I still get 3x is equal to 27. X is 9. Okay, so lots of different ways you guys can set up these proportions. Just make sure you're consistent. Okay, let's move on to the back here. All right, this is our angle bisector theorem. How do I know that? Because we have these little arcs right there, so that means that's an angle bisector. So whatever those angles are, they're the same measure. And our angle bisector theorem says that the angle bisector splits the sides of the triangles so that they are proportional. So once again, I'm going to do the same concept. I can go left over right equals left over right. I can do top over bottom equals top over bottom. I'm going to choose to go left to right again. That's just kind of me. That's just what I do every time. Okay, so but here we got to stop for a second. This little piece is x, and this whole piece is 8. So what do I put for this guy right here? What do I put for that piece? Put in a number. If x were 2 and the whole length were 8, then this would be 6, right? You just did 8 minus 2. So if this is x, then this piece is going to be 8 minus x. That piece is going to be whatever the whole length is. It's going to be 8 minus whatever that piece is. All right, so now I can set up a proportion that says that this ratio, left over right, equals left over right. 5 over x, left over right, equals left over right. 7 over x minus 8. Okay, I'm going to cross multiply. I'm going to get 7x is equal to, now when I cross multiply here, that's the distributive property. It's 5 times all of that stuff. Okay, so I get 7x is equal to 40 minus 5x, just distributed. I'm going to add 5x to both sides. Cancel, I get 12x is equal to 40. Okay, divide by 12. And x is equal to 40 over 12. Okay, they're both divisible by 4. So that simplifies to 10/3, or 3.3 repeating. Okay, now let's check this. Okay, on my calculator, okay, let's do the ratio again. Let's do 5 over x. 5 divided by, our answer is 10/3. So I've got to put that in parentheses. 5 divided by 10 divided by 3. I'm dividing by a fraction. Okay, that's 1.5. So the ratio of 7 over this piece also has to be 1.5. Okay, so 7 over 8 minus x. Well, what is 8 minus x? We got to do that first. 8 minus 10 divided by 3. It's going to give us that piece. But then it's 7 over that. Okay, so I'm going to press 7 divided by. Now here's a little trick you guys might not know on your calculator. This little button down here where the negative sign is, see right above it in blue it says ANS? That means answer. Okay, so instead of me having to type this whole thing back in again, I'm just going to type 7 divided by second answer, because my calculator sees that as 7 divided by whatever you had previous. Okay, that better be 1.5. Okay, and without the glare, it is 1.5. All right, so those ratios check out. Okay, oh my goodness, are you guys ready? You guys ready for the big bad baby mama papa? Baby mama papa. Okay, so I'm going to grab my old book that I used to use at my old high school. I'm going to put this under the screen here again. This is the way I taught you guys in class. There are 2 ways to do this, okay? The first way that I offered you are with these little formulas. I took these nasty corollaries that are unbelievably confusing, and I broke it down into 3 different short proportions that you can use to solve for the lengths of the side of a triangle when you draw this altitude. So our theorem says when you draw an altitude in a right triangle, it splits up the triangle into 2 other smaller triangles where all 3 triangles are similar to each other. And the reason why that is because of angle-angle similarity. Okay, because I've got an angle there and I've got an angle there. Okay, so when I split this up, I have 3 right angles, and then but they are also sharing this other angle, so they're similar because of angle-angle similarity. Okay, angle-angle similarity. Okay, so once again, if you guys took a picture of this in class, that's fine. I'm showing it to you here in the video. So our first little proportion, you've got the original hypotenuse of the original large triangle. I wrote that in pink. Then this hypotenuse is broken into 2 pieces of the hypotenuse. You got this long hypotenuse, HYP hypotenuse, long height, and then you got the short piece, the short height. And then you have the short leg of the original large triangle, and then you have the long leg of the original large triangle. And then you have the altitude in the middle, ALT. So one of our proportions says the ratio, the short height divided by the altitude, okay, is going to be equal to the altitude divided by the long hypotenuse. So short piece over altitude equals altitude over long piece. Okay, so that's one little formula you can remember. Think T. If you guys can see kind of like the upside down T right here. Short height over alt equals alt over long height. Okay, the second formula is height over long leg equals long leg over long height. Okay, so the original hypotenuse over the long leg is equal to the same long leg over the long hypotenuse. Okay. Third one is the whole original hypotenuse of the large triangle over the short leg over this piece is equal to that same short leg over the short height. Okay. Now, again, I offer you guys this. If you're one of those students that likes formulas, you're good at memorizing stuff, knock yourself out, memorize these, and you can use this on your test to solve for the unknown lengths. In my experience, most students have a tough time remembering those, so they're going to use the second strategy, the second alternative for the way that I present this information, and that's to use my baby mama papa triangles. Okay, so what we're going to do in each of these triangles, there's altitude, 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 all these have an altitude. So basically these are 6 of the same different types of problems. Some of them have 1 variable, some of them have 3 variables. Okay, so we got different levels of difficulty here. I'm going to tell you guys right now, if you use my second strategy of the baby mama papa, you got no shot at doing this unless you guys draw these triangles out. We're going to relabel these triangles. We're going to redraw these. Okay. Now, I tried to leave you guys a lot of room on your test review here, but you still kind of have to write small. I'm actually going to redo these on a separate sheet of paper, one at a time, just so you guys can see visually what's going on here. So I'm going to take the first one. I'm going to redraw this. Redraw this triangle. I'm not going to use a ruler for everyone. I'll do my best. We have an altitude 1, x, 9, and y. Okay, so in this first problem, here's what I have. Okay, now I'm going to redraw these. I'm going to try to do this. I'm going to try to color code these guys for you. I'm going to do these in 3 different colors. I'm going to do my baby triangles in blue. Okay, so this is my baby triangle in blue. I'm going to do my mama triangles in green, the medium-sized triangles, and then I'm going to do the large triangles in red, the original large triangle. Now guys, you got to understand something. Y'all cannot sit here and watch me do these. This is a very tough concept. Y'all cannot absolutely sit here and just watch me do these and just copy it down and say, okay, I think I kind of know it. If you're struggling, watch me do this first one, and then I need you guys to work the rest of them on your own. Okay, don't just sit there and watch this, because you'll think you have it and you'll get to the test. You're like, oh my gosh, I don't understand how to do this. So watch me do one and then try a couple on your own. If I can get it to focus. Okay. Now, what I've taught you guys to do in class is to make up some numbers here. Okay? Make up some numbers. This is a right angle as well. Make up some numbers. I always use 30, 60, 90. To me, that's just the easiest way to do it. Okay, so I'm going to make up a number. I'm going to assume that that's a 30-degree angle. This is a 90-degree angle. So that means that if this is 90 and this is 30, this angle up here has to be 60 degrees, right? Because 30, 60, 90 add up to 180 degrees. Okay, now that's on the big Papa triangle, on the red triangle. All right, now in the Mama triangle, looking at the green triangle, my right angle is right there. And if this is 30 degrees, what does this angle of the green triangle have to be? Maybe I should do this in the same color. This guy has to be 60 degrees. Okay, I'm looking at the green triangle. 30, 60, 90. And then in the blue triangle, looking at the baby triangle, that's a 60, that's a 90, this has to be a 30. Okay, 30, 60, 90. All 3 triangles are 30, 60, 90. Now I'm going to redraw these 3 triangles. Okay, there's my baby in blue. There's my small triangle. I'm going to orient these triangles all in the same way. Okay. All right, so I'm always, to me personally, I'm going to put the 60 up here. I'm going to put the 30 degree down there. Okay, now for my mama triangle in green, it's a little bit bigger. It is still a right triangle. I'm still going to have 60, 30. That's my mama triangle. And they have the original large red triangle. Okay, that's my Papa triangle. Okay, 90, 60, 30. So now we go back to our diagram and make sure we are oriented correctly. For the large triangle, for the Papa triangle, okay, we got this X over here. Where is the X on the large triangle? Now that's my 30, that's my 60, this is my 90 for the large triangle. The X is between this 60 and this 90, right? So it's between the 60 and the 90. So the X goes right here, okay? In this particular case, the red triangle and the red triangle are oriented the same way, so I can just look at it. Y is between the 90 and the 30. X on the left, Y on the bottom, Y on the bottom. Now my hypotenuse is this piece, the long height, plus the short height. So I've got to add the 1 plus the 9, gives me a hypotenuse of 10. Okay, so we've labeled everything we can label on the Papa triangle. On the Mama triangle, I'm looking at the green triangle. Okay, where's the 9 on the green triangle? The 9 is between the 90-degree angle and this 30, between the 90 and the 30. 90 and 30, so the 9 goes right here. The Y, for the green triangle that's upside down, the Y is across from the right angle. So the Y is the hypotenuse. It's between the 60 and the 30. Okay, so the Y goes here. And then that's all I can do on the Mama triangle. All right, for the baby triangle, looking at the small guy, the 1 is between the 90 and the 60. Between the 90 and the 60, so the 1 goes there. The X is between the 60 and the 30, or it's the hypotenuse of the baby triangle. And that's all I can do. Okay. So I've labeled everything as much as I possibly can. All right. So now it's time to set up our proportions. All of these triangles are all similar because of angle-angle similarity. So I can say that the left piece over the left piece equals the bottom over the bottom, which equals the hypotenuse over the hypotenuse, and I can start setting up proportions. Okay, so for x, all right, so for x I see, I guess I'll go back to purple. For x, I see an x here and a 1 there, and I see an x here and a 10 there, which is good. I've got two hypotenuses, hypoteni, I don't know. I've got two hypotenuses and two legs on the left. So I can set up a proportion. I can go left over left equals left over right equals left over right. I can go leg over hypotenuse equals leg over hypotenuse. I just got to be consistent. I'll go from left to right. 1 over x is equal to x over 10. Okay, now when I cross multiply, x times x gives me x squared. 10 times 1 equals 10. Now when I take the square root of both sides, I end up with the square root of 10. I cannot simplify that radical, so that's the best that I can do. All right, now for my y's, okay, so I've got a y here, so I've got a y on the hypotenuse, I have a hypotenuse, I've got a 9 on the bottom and a y on the bottom. So I'm going to go left to right, y over 10 equals 9 over y. Again, I could have done y over 9 equals 10 over y. Cross multiply, I get y squared is equal to 90. Take the square root of both sides. Now the square root of 90 I can break down. I gotta, because on the test you guys are going to have to simplify your radicals. You can't just type in a decimal. Okay, it's just one of these things in math. It's one of our standards. We just have to know how to do it. All right, so in order to break down a perfect a square root, you look to see what is the highest perfect square that divides evenly into that number. 1 squared is 1, 2 squared is 4, 3 squared is 9, 25, 36, 49, 8 squared is 84, 7 squared is 49, 8 squared is 64, 9 squared is 81, and then 100. Okay, so I'm looking to see what is my highest perfect square that divides into that. Well, a 9 goes into it. Okay, so I'm going to break this down into the perfect square land and the garbage can. Okay, the perfect guy is 9. He's perfect. Okay, 90 divided by 9 is 10. 10 is garbage. I cannot take the square root of 10. Okay, so the square root of 9 I can take. Okay, square root of 9 is 3, so this is 3 root 10. So y is equal to 3 times the square root of 10. X is just the square root of 10. Okay. All right, I know that's a lot, guys, so rewind the video if you need to. Okay, don't watch any more of this video. If you haven't done any of these problems yet, don't watch any more of this video until you guys go on and work out number 27, 28, 29. If you're really confused, come back to the video, okay? But I'll need you guys to work through a couple on your own and then play the video with me walking you through it. Okay, so I'm going to do number 27 here. Number 27 is this problem. So once again, I'm going to redraw this on a separate piece of paper so I can spread everything out and have a lot of room. Yeah, something that looks like this. Got a box here, which means that's a box. We have a y right here. We have an x right here. We have a 6, and we have a 2. Do I have anything else? Oh, that's it. Okay, here we go. Baby, 60, 90, 30, baby, Meemaw. You guys ever call your mother Meemaw? 30, 60, that's mama triangle. And we got Pops, Pappy, Papa. We got Papa, baby mama, Papa. 60, 90, 30. Okay, now let's go back to our original triangle. Let's put some numbers in. All right, when you do this, guys, you're always going to end up putting in two 30s and two 60s. Okay, so there's a 30, which means on my original triangle, that's one of my 60s. Okay, if this is 60, then this little angle is 30. If that's 30, then this one has to be 60, because 30 plus 60 equals 90. All right, now it's time to start filling in some stuff. On my baby triangle, on the little bitty baby triangle, okay, 2 goes between the 60 and the 90, 60 and 90, so the 2 goes there. The y goes between the 90 and the 30, so between the 90 and the 30, so the y goes there. Okay, On the mama triangle, the middle triangle, middle. Okay, on the middle triangle, x is the hypotenuse. 6 goes between the 90 and the 30. And the y goes between the 90 and the 60. So I can label all three sides for the mama triangle. For the papa triangle, the original triangle, x goes between the 90 and the 30. So x goes there. The hypotenuse is 6 plus 2, which is 8. And can I label anything else? No, that's it. Okay, so first off, I want to see, can I set up a proportion for my x's? Okay, I see an x there. I see an x and an 8. Okay, those are both, I have numbers for both of those. And then I see a 6 and an x. I have numbers for both of those. So we're good to go. I'm going to go, this time I'm going to go top to bottom, just to show you get the same thing. I'm going to go top to bottom equals top to bottom. X over 6 equals top over bottom, x over 8. Cross multiply, you get x squared equals 48. Okay, take the square root. Is there a perfect square that goes into that? Yes, there is. 4 definitely does, but 16 does as well. So I'm going to break that down into perfect land. 16 is a perfect land. 16 times 3 is 48, so 3 is the garbage. I can't do anything with the square root of 3. Square root of 16 is 4, so that's just 4 root 3. Okay, now watch what happens if you didn't do this correctly. Watch what happens if you did 4, if you broke this down into 4. Square root of 4 and the square root of 12. The problem with that is that 12 is still perfect because I can break that down into the square root of 4 and the square root of 3. Well, the square root of 4 is 2, and the square root of 4 is 2, so I have 2 times 3, which is, this breaks down into the square root of 4 and the square root of 3. The square root of 4 is just 2. So this breaks down into 2 times the square root of 3, which still gives me 4 root 3. Okay. So if you don't pick the highest perfect square when you simplify these radicals, that's not the end of the world. You just have to do another step. Okay, all right, so we said x is equal to 4 root 3. All right, now I'm looking at the y's. I have a y over here and a number over here. I have a number over here and a y over here, so I'm good to go. This time I'll go left to right. 2 over y equals left over right, y over 6. Okay, if you cross multiply, y squared is equal to 12. Take the square root, and I just showed you this, so it's fresh in your mind. 12 breaks down into the square root of 4 and the garbage, square root of 3. Square root of 4 is 2, so this simplifies to 2 square root of 3. And that is what y is. I could have solved for y first in this one, but I chose to go with x. Sometimes you might need to actually solve for one of the variables first before you can find the other ones. Okay, that's number 27. Let's go on to number 28 on the review. This is the easiest of the 6 because there is only one variable to solve for, actually. Okay. All right, so here we go. Okay, we have something like this. Box and box, original box. This is an X, this is a 4, and this is a 10. All right, baby triangle, baby, 60, 90, 30, baby triangle. That's this guy. Oh, I need to put the numbers in. I'll put a 30 here and a 60 here, 30, 90, 60, 60, 90, 30. Okay, so for the baby triangle, the 4 goes between the 60 and the 90, so the 4 goes there. X goes between the 30 and the 90. Oh, I'm sorry, that's on the mama triangle. So for the baby, all I can do is the 4 goes between the 90 and the 60, and the 10 goes between the 90 and the 30. So the 10 goes there. All right, for the mama triangle here in green. Mama triangle in green, 60, 90, 30. For the mama triangle, the 10 goes between the 60 and the 90. Okay, so 10 there. And then the X goes between the 30 and the 90. So the X goes there. Now, I actually don't even need to draw the papa triangle in this one because I have what I need. There's only one variable, so I have the 4 and the 10 and the 10 and the X. I'm good to go. So I'm going to say left over right, 4 over 10 equals left over right, 10 over x. Cross multiply, I get 4x is equal to 100. Divide by 4, and we get 25. So that was pretty easy. Okay, so now we have one more that has two variables in it. Okay, so I'm going to do this one here, number 29. So 29, we have something like, let's see this. So this is number 29. Okay, so I have a 6 here, an x, I have a y, I have a 14, and this is a right angle. Let's put in our numbers. I'll put the 30 here, the 60 there. If that's 30, this is 60, which means this one's 30. Okay, so let's do our baby. 60, 90, 30. This is my baby, the smaller triangle. Okay, so the 6 goes between the 60 and the 90. The x is the hypotenuse between the 60 and the 30. And the y is between the 90 and the 30. Okay, so there's my baby triangle. Mama triangle here in green. Okay. 60, 90, 30. And these all have to be oriented the same way, guys. If you notice, the way I'm drawing these triangles is always 60, 30, 90, 60, 30, 90, 60, 30, 90. Okay, you can't be switching these up. That defeats the whole purpose of what we're trying to do. Okay, so for the 14 is between the 90 and the 30 on the mama triangle. The y is between the 90 and the 60. And that's all I can do for the mama triangle. For Papa, the original large triangle, okay, x is between the 60 and the 90. Okay, the hypotenuse is the 6 plus the 14, which is 20. And that's all I can do. Okay, so now how do I set a proportion for this? Okay, I've got a 6 and an x and a 20. So I'm good to go. I can go left over right. 6 over x equals left over right, x over 20. When I cross multiply, I get x squared is equal to 120. Okay, take the square root of both sides. I get x is equal to, now here you got to break this down. What is the highest perfect square that goes into 120? You might think there's a big one, but actually there's not. The highest one is just a 4. I can break this down into the square root of 4 and the square root of 30. There's no perfect square. 4, 9, 16, none of those go into 30. So 30 is in my garbage can. Square root of 4 is 2. So x is equal to 2 times the square root of 30. All right, for my y's, okay, I've got, let's see, I got a y here. So I've got a 6 and a y and a y and a 14. All right, I'm going to go backwards this time. I'm going to go right to left. I'm going to go 14 over y. Right over left equals right over left. Y over 6. Okay, cross multiply, you get y squared is equal to 84. Okay, take the square root of both sides. What is the highest square that breaks down into 84? Once again, the best I can do is a 4. That's the square root of 4 and the square root of 21. 21's in the garbage can. Square root of 4 is 2. So y is 2 times the square root of 21. Okay, so that takes care of 29. All right, here we go. Now we get to some of the difficult stuff where we have 3 variables. 3 variables, fun stuff, fun stuff. I love it. Okay, so I'm going to do number 30 here. Okay, so let's redraw this one real quick. So I have something that looks like this. My original right angle. These two are right angles. Let's put in our numbers. I'll put a 30 there, a 60 there, which means that has to be a 30 and that has to be a 60. Okay, this is an X, this is a 12, this is a 3, and this is a Y. All right, baby. 60, 90, 30. Okay, for my baby triangle, this guy right here, 3 is between the 90 and the 60. Y is the hypotenuse, and oh, I have a Z here. I have a Z. Okay, so the Z is between the 30 and the 90. So I've got a Z there. Okay. Okay, for my mama triangle, 60, 30. Okay, for my mama triangle here in green, the X is the hypotenuse across from the right angle. The Z is between the 60 and the 90. And the 12 is between the 30 and the 90. Okay, ZX12. Papa triangle. 60, 90, 30. Okay, for my Papa triangle, X is between the original 90 and the 30, so X goes here. The hypotenuse is the 12 plus the 3, that's 15 for the whole hypotenuse, and the Y is between the 60 and the 90. Okay, so I got everything labeled. So now everything's the same, I just have an extra variable to solve for. Okay, let's start with X. Can I do anything with X? I have an X and a 15 and 12 and an X. Yep, so I can set that up. Left over right, X over 15 equals left over right. 12 over X. Cross and multiply, and we get X squared is equal to, I believe that's 180. Take the square root of both sides. The highest perfect square that goes into 180 is actually 36. And then 5 is in the garbage can. 36 is one of our perfect squares. Square root of 36 is 6. So X is equal to 6 times the garbage can. 6 times the square root of 5. Okay, for the Y's, let's see what I got for the Y's. I have 3 and a Y and a Y and a 15. Okay, very good. I can say 3 over Y equals Y over 15. Cross multiply, I get Y squared is equal to 45. Take the square root. The highest perfect square that goes into 45 is a 9, so I'll break this down into perfect land. And Mr. 5 is very unhappy. He's always in the garbage. Square root of 9 is 3, so Y equals 3 times the square root of 5. Okay, and then Z. Okay, here I have a 3 and a Z and a Z and a 12. Okay, so I can set this up. I can say 3 over Z equals Z over 12. Get Z squared is equal to 36. Take the square root of both sides, and I get Z is equal to 6. Let me check sure and make sure I did that correctly. 3 over Z equals Z over 12. Yeah, so that's correct. Alrighty. Okay, I just want to check, make sure that was right. Okay, last one here. Last difficult one. So now I'm doing number 31 here. Okay, so I have that's 12 box 8x y box. Just throw in our magical fairy tale numbers, 30 and a 60, which means that's a 30 and that's a 60. And we're ready to draw baby. 60, 90, 30. Here's my baby, the small triangle. So 8 is between the 60 and the 90. 12 is the hypotenuse between the 60 and the 30. And y is between the 90 and the 30. Here's a baby. Mama, Meemaw. Okay, for the mama triangle. And bring colored pencils if you guys need to color code these. You're more than welcome to do that. I'm a big fan of that. X is between the 90 and the 30. Y is between the 90 and the 60. And we don't have a hypotenuse. Oh, yes, we do. I keep forgetting the Z. There's a Z there. Okay, so Z is the hypotenuse between the 30 and the 60 on the mama. Okay, Papa, Pappy. Okay, so my original red large triangle. Okay, Z is between the 90 and the 30. 12 is between the 60 and the 90. All right, now here my hypotenuse is actually x plus 8. A little tricky there, x plus 8. Okay, now, where are my x's? Where are my x's? Okay, I've got an x down here. I got an x over here. What can I set up? I got an x and a 12 and an 8 and a 12. Okay, so I can work with that. So I got an 8 and a 12 and a 12 and an x plus 8. So I'll go left over right. 8 over 12 equals left over right. 12 over x plus 8. Okay, now when I cross multiply, I get 144. On a cross multiply here, I got to distribute 8 times x plus 8. Don't forget to put that in parentheses. So you have 144 equals 8x plus 64. And then we're going to subtract 64 from both sides. I get 8x is equal to 80. So x is equal to 10. Okay, rewind these videos, guys, if you think I'm going too fast at any point. All right, for the y's, where are my y's? I have a, well here I have an 8 and a y and an x, but we just found x. X is 10, so I can work with that. I can go 8 over y equals y over x, which is 10. So y over 10. Cross multiply, I get y squared is equal to 80. Take the square root. The highest perfect square that goes into 80 is 16. So it's the square root of 16, and the garbage can is 5. Look at that. Mr. 5 just so unhappy, always in the garbage. This simplifies. Square root of 16 is 4, so this simplifies to 4 root 5 for y. All right, for z, where are my z's? I have a z and, what's the best way to do the z? I guess we'll go z, and then we have the actually it might be easier to use these. I have an 8 and a y and a 12 and a z. Maybe it's easier to do with that. I'm going to use the baby and the mama triangles. I could have used the mama and the papa, but I feel like this is going to be a little bit easier. I'm going to go left to right, 8 over y. 8 over y equals 12 over z. Okay, so what is y though? We solved for y. Y is 4 root 5. So I'm going to go 8 over 4 root 5 equals 12 over z. I just plug this in right here. All right, so now when I cross multiply, 8 times z is 8z. When I multiply 4 root 5 times 12, all you do is you multiply, it's almost like a 4x. If you did 4x times 12, that's 48x. If you do 4 root 5 times 12, that's 48 root 5. You treat the radical kind of like a variable. You just multiply the coefficients and numbers in front. Okay, 8z equals 48 root 5. I'm going to divide both sides by 8. 48 divided by 8 is 6. So z equals 6 root 5. Again, treating that radical like it's a variable. Tough stuff, guys. Tough, tough, tough. Go back and watch this portion of the video as many times as you need to make sure you understand how to do these. Okay, last few problems here on the home stretch. Going back to number 32, I'll go back to my test review here. A 1.4 meter tall child is standing next to a flagpole. The child's shadow is a 1.2. The shadow of the flagpole is 7.5. How tall is the flagpole? So this is our tree. Flagpole problems. So we've got the sun that's kind of beating down, giving us a shadow. Okay, the shadow, it says the shadow of the flagpole is 7.5. So this whole distance is 7.5 meters. Okay, then we have a person, a child that's 1.4 meters tall. And the child's shadow, this shadow is 1.2 meters long. and they're asking us to find the height of the flagpole. So please, guys, draw yourself a picture to make sure you're setting these up correctly. I'm going to go left over right. I'm going to go height over height equals shadow over shadow. Left over right equals left over right. So the height of the flagpole over the flagpole's shadow is equal to the height of the child over the height of the child's shadow. When I cross multiply, I get 1.2x is equal to 10.5 divided by 1.2, and I get x is equal to 8.75 meters. Okay, does that make sense? Yeah, it makes sense. The child's height's a little bit more than the child's shadow, so the flagpole height should be a little bit more than the flagpole shadow. So yeah, that makes sense. I buy that. It sounds reasonable to me. Okay, last couple of problems here. This is another angle bisector theorem problem. I'm going to go, we got our two arcs here, so angle bisector theorem. I'm going to go left over right equals left over right. X plus 4 over x minus 2 is equal to left over right. 2x plus 3 over x. Okay, when I cross multiply here, it starts to get a little tricky. X times x plus 4. Now when I cross multiply here, I've got x minus 2 times 2x plus 3. Okay, we got to do some simplification. We got to distribute here. This one I just distribute twice. X times x is x squared. X times 4 is plus 4x. Now here we got a FOIL, right? Whenever I multiply a binomial times a binomial, I got to do first, outside, inside, last. So first, x times 2x is 2x squared. Last, x times 3 is plus 3x. Inside, negative 2 times 2x is minus 4x. And then last, negative 2 times 3 is negative 6. Okay, all right, so now we need to simplify and combine our like terms. So I have, I'm going to come back up here. I have x squared plus 4x equals 3x minus 4x is negative x. So I have 2x squared minus x minus 6. I got a quadratic because my highest exponent is a 2, so I need to have this set equal to 0. So I'm going to subtract x from both sides. Okay, subtract x squared from both sides. So I have 4x is equal to 1x squared minus x minus 6. Now I'm going to subtract 4x from both sides. So I have x squared, negative x minus 4x is minus 5x, minus 6, and all that. They canceled on the left, so I just have a 0. So now I got my quadratic set equals 0. How do you solve this quadratic? You're going to factor when a equals 1. Okay, I can't do the GCF, I can't do special case, no square root method. So when a is 1, when that's an understood 1, I repeat, I do not need to do the rainbow thing. There's no reason to split this middle term up. Okay, there's no reason to factor by grouping. You're just making life difficult for you. When a is 1, I simply look at this guy right here. I look at my C term. What are the factors of C that add to B? What are the factors of negative 6 that add to negative 5? The only two combinations are 6 and 1 and 3 and 2. Okay, and actually both of these will get me to a 5, but I can't, the 6 is negative, so that means one's positive, one's negative. I can't get to a 5 with 3 and 2 if one's positive, one's negative. So that tells me it's got to be a 6 and a 1. Okay, now which one's positive, which one's negative? The sign of the middle term tells you the sign of the bigger one. So the bigger one, 6, has to be negative. So this is going to factor is x minus 6 and an x plus 1. Okay, FOIL it back out if you're not sure. First, outside, inside, last. Flippy flip, I get x is equal to 6 and negative 1. Negative 1 does not work because negative 1 minus 2 gives me negative 3. I can't have a negative length, so the only one that works is 6. X is 6. Number 34 is the corollary to our side splitter theorem. It says lines that appear to be parallel are parallel. So our corollary says if all these lines are parallel, these transversals will cut these pieces into segments that are proportional. Okay, each of these pieces are proportional. So it's the same concept as always. You can go left over right equals left over right, top over bottom equals top over bottom. I'll stick with left to right. So I'm going to say that x minus 5 over x minus 2. Left to right on top equals left to right on bottom. X minus 1 over 2x minus 1. Okay, now when we cross multiply, we got a FOIL again. I'm going to have x minus 5, this piece times 2x minus 1 equals x minus 2 times x minus 1. Okay, I'm going to have FOIL twice. First, outside, inside, last. That's 2x squared minus x minus 10x. Negative 5 times negative 1 is a positive 5. Okay. Okay, over here. Oh, that's a plus 1. I was about to say, I'm looking at my answer key. I knew something was wrong. This is a plus 1. Yeah. Okay, so x times 2x is 2x. X times 1 is a positive x. That's negative 10x, and this is a minus 5. Sorry, it's a minus 5. Okay, now when I FOIL over here, x times x is x squared. X times negative 1 is negative x. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2. Let's combine our like terms. Over here I have 2x squared minus 9x minus 5 equals, this is x squared, combine those, minus 3x plus 2. Now I need to get my quadratic set equal to 0. So if I subtract x squared from both sides, I'll have 2x squared. If I subtract x squared, I'm going to add 3x. 3x minus 9x is minus 6x. And then I'm going to subtract 2 from both sides. That's going to give me a minus 7 equals 0. Okay? And that's a single x squared. Yeah. Subtract x squared from both sides, I get 1x squared. Okay, so let me come back up here. So I have x squared minus 6x minus 7 equals 0. Once again, guys, I do not need to do the rainbow thing because this leading coefficient is a 1. What are the factors of negative 7 that add to negative 6? That is going to be a negative 7 and a positive 1. And I flippy flip, I get x is equal to 7 and negative 1. Once again, negative 1 doesn't work. Negative 1 minus 2 is negative 3. So the only answer that works is 7. All right, a lot of stuff. Again, go back and rewind it. YouTube is a wonderful thing. Go back and rewind this if you're having trouble with these. And then the last one here, I'm just asking you, this really doesn't have anything to do with geometry. I'm just asking you guys to solve this because I still feel like we're weak on solving quadratics when a is not equal to 1. Okay. All right, so let's get my quadratic set equal to 0. So I'm going to move the 5r to the other side. And I'm going to add 4r to both sides. Those cancel. So I have 7r squared plus 40r minus 12 equals 0. Okay. Now on this one, you can't just say what are the factors of negative 12 that add to 4 because my leading coefficient, is not a 1. And notice here, guys, I say don't use a quadratic formula. I've noticed several of you guys are using quadratic formula on your quizzes and tests. And yes, while that's correct, that will always work. When you guys get to advanced algebra next year, you're not going to be able to use the quadratic formula when you factor because you're going to be dealing with cubics. And quadratics only deals with x squareds. So what are you going to do when you get to x to the third? Okay, so if you can factor these things, you really need to work on this skill. All right. Now I do need to do the rainbow thing. A times c, 7 times negative 12 is negative 84. And I need to find factors of negative 84 that add to positive 40. Okay, if you struggle with doing that in your head, use the trick that I showed you. On your calculator, go y equals, and I'm going to type in this number, 84 divided by x, and go second table, and I'm looking for numbers that are basically 40 apart. Here we go right there, 2 and 40. Y'all can't see that. So I see right here, 2 and 42 are 40 apart. Okay, which one's positive? The middle term is positive, so the big one has to be positive. So that's going to be a positive 42 and a negative 2. So I'm going to split this middle term. I'll put the 42 over here, plus 42r, whoops, let me write this again, 7r squared plus 42r, and I'll put the negative 2 over here, minus 2r minus 12 equals 0. Okay. Now I just split $40 into $42 minus $2. It's still $40. But now I can draw my curtain and I can factor by grouping. On the left hand side, my GCF is 7R. That's going to leave me with r plus 6. Over here, see that negative right there, guys? You got to pull out that negative. I'm going to factor out a negative 2. That will also leave me with r plus 6. Okay, so they match. That's good. All right, so my two factors are r plus 6 and the stuff left over on the outside, 7r minus 2. This is all equal to 0. This one I can flippy flip. This one I actually have to solve. Okay, you got to solve 7r minus 2 equals 0. Move the 2 to the other side. Divide by 7, and my other answer is 2/7. Okay, so it's negative 6 and 2/7. I don't need to check either of these because this is not a geometry problem. I'm just asking you to solve this quadratic equation. Now you can take your two answers and plug them back in and make sure that the left side equals the right side. Okay. Long video, guys, hour and 25 minutes, but like I told you guys, this is one of, if not the hardest unit in geometry with all these proofs and quadratics and simulating right triangles, baby, mama, papa. So tough sledding here. So, but I'm confident you guys study hard and watch this as much as you need to, and we will see you on the next video. Good luck on your test.